Morning, madam and friends. Welcome to our presentation. We are from Group 5, and our case study is National Institute of Advanced Industrial Science and Technology. Our project title is Highly Scalable Mission Critical System Consolidates and Optimizes Entire Business Process on a SPARC Enterprise Platform. My name is Wong Seng-Kun, and I have my group mates who are Chu Yong-han, Chan Yue Wah, and Chin Hong Jie. Without further ado, let's start our presentation.
A very good day to total. My name is Johan, CA1808. Now I present introductions, issues, and solutions. So for introductions, National Institute of Advanced Industrial Science and Technology, or named as AIST, is a research facility that located in Tokyo, Japan to solve environmental issues across the globe. But they have faced the system performance inefficiencies and growing workload problems. So they want to improve their system productivity and efficiency. Hence, they have developed a software development methodology named Package Development Framework. So to support their methodology, they have chosen a system use Fujitsu server, storage, and system management utility. So the next part is issues. So for the issues, our group has identified 3 issues. Number 1 is performance insufficiencies and obsolescence for mission critical system because they are unable to handle a huge customer demand and larger workloads, and their former system is unable to adapt to new technologies when adding resources. And then the result from database server are incorrect with corrupted information to be displayed. Number 2 is they want to enhance business continuity because their former system is easily get affected by disruptions such as power outage, natural disaster, and so on, and easily to go offline to them and damage rapidly. Besides, growing workload cause their former system is unable to perform well. The number 3 issue is lack of flexible resources allocation on performance because their former system is unable to adapt to future advancements on system organization change and workload growth. And their system is unable to ensure data integrity and system stability. Moreover, their system is unable to adapt to current trends such as technology changes. Besides, their system is unable to customize CPU and memory allocations with flexible when meet the specific conditions. The next part is method or solutions. So for the method, so here we have proposed 3 methods to solve the database server performance insufficiency and future workload ground. Firstly, we have proposed them to re-engineering their mission critical systems. So they can use the new system consists of 3 tiers, which is web servers, application servers, and database server, because they are supported at the core of their mission critical system and having the high scalability, reliability, and performance. Second, to solve the business continuity in low performance, we propose them to consider these 4 measures. Number 1 is hardware partitioning. Number 2 is dynamic reconfigurations. Number 3 is capacity on demand. And the last is scalable memory resources. So for the number 3, to solve the lack of flexible resource allocations on performance, here we propose them to apply flexible configurations change that allow the swift resources in line with business expansions. So here we have proposed the devices for our methods, our proposed method. Firstly is SPARC Enterprise M8000 server with prime cluster. They will act as the mission critical database system. So to overcome future growing workload, we suggest them to adapt 2 servers. Number 2 is SPARC Enterprise M4000 server, and this will act as the backup server of critical database. And the lastly is Acternus 4000 model 500 disk storage with OPC functions to ensure operational continuity and prevent data loss in business continuity. So that's all for my part. Thank you.
My name is Chin Hong Ji, matrix number CA19034. Now I present the implementation and configuration part. For the software parts, Prime Cluster is a Fujitsu clustering software. Prime Cluster is scalable to monitor up to 6 nodes at the same time and also high availability on monitor the nodes. Prime cluster will detect the SPARC enterprise server while they're facing any failure and switch to another available SPARC enterprise server to continue the operation. For hardware parts, there are two SPARC enterprise M8000 servers, one SPARC enterprise M4000 servers, and one Ethernet 4000 model 500 is configured in the system. So for SPARC enterprise M8000 and M4000 server, they implement the hardware partitioning. Hardware partitioning is separate the application into each partition, or also named as the dynamic domain, with the available resources such as the processor or the memory from the resources pool. Hardware partitioning will ensure the failure of application in current dynamic domain will not affect to the application in other dynamic domain. Hardware partitioning will use the dynamic reconfiguration and the capacity on demand function to edit the configuration of partition. Dynamic reconfiguration is used to manage the hardware resources of the dynamic domain based on the workload without making the SPARC enterprise server down. Dynamic reconfiguration will allow the SPARC enterprise server operate the server maintenance and hardware resources change without influence the server uptime. For SPARC Enterprise M8000 server, the dynamic reconfiguration will apply multiple CPU memory board to each dynamic domain. So when the resources such as the processor detect the failure, the CPU memory board will be isolated and remain the available memory board continue the operation. For capacity on demand, it will use reserved resources in the SPARC Enterprise server to manage the change of the workload in the partition. This function will automatically activate the available resources when the partition requests for additional resources. For scalable memory resources, SPARC Enterprise use the memory mirroring to separate the memory into two and replicate the data into both memories. When read data processed, the memory access controller will use the ECC to check the availability of both memories. If memory access controller didn't detect a failure on both memory, the both memory will be compared, and the suitable memory will be selected to read the data. If one of the memory detect the failure, the another memory will be used to read the data. SPARC Enterprise Server also use the memory patrolling in scalable memory resources. Memory access controller will use the ECC detect the failure memory and isolate the failure memory without affect the operation of the application. Memory patrolling is fast on detecting the failure and also not consuming other resources such as the processor. For Ethernet 4000 model 500, it used the one-point copy, which is the advanced copy function to copy the data from the business volume to the copy volume. The one-point copy function will copy the data in a short time. The copy volume data will store as the backup data, while the database server will continue their operation using the business data volume. For my part, and I will pass to next member to present.
Hello and good days, my name is HUE WAH matrix ID CA19059. Now I'll present about the features of a new device or improvement. These are the hardware and the software that will be used for the mission critical database server. So firstly, is the Prime Cluster software. This software has the features of the data management, high availability and efficiency, as well as its support for the large-scale logical volume of data. It's also able to maximize the server utilization by identifying the issues that occurs, and it will automatically switch the operation to the backup server. Next, we will discuss the features of the SPARC Enterprise M8000 and M4000 server. For the mission critical database server, we decided to use two SPARC Enterprise M8000 as the main server and one SPARC Enterprise M4000 as the backup server. Both M8000 and M4000 server also share some similarity features, like both servers also have the memory interleave technology, which will speed up the memory access. Both servers also using the prime cluster software that provide the system redundancy. It also contains error checking and correction ECC protection features. Therefore, the system performance can be improved with the ECC protection and the system redundancy. But there are also some different features between SPARC Enterprise M8000 and M4000 server. For example, M8000 server contains a maximum 128 thread, 12 MB of level 2 cache memory, and 184 GB per second of the data transmission speed, while M4000 server only have maximum of 32 thread, 11 MB of the level 2 cache memories, and 32 GB per second of the bandwidth. Then will be the storage Athenos 4000 Model 500. This hardware has 16 server interface rows and 32 GB of the cache memory storage that will improve the availability of the system. Athenos 4000 include the 128-bit of the data encryption functionality that will ensure the security of the system. It also contains the OPC one-point copy and RAID 6 parity checking functionality that helps in the data transmission rapidly and accurately. Now we will discuss about the advantages and the disadvantages of the new devices. Firstly, SPARC Enterprise M8000. The advantage of this server is scalable for future workload increase because every new application may be installed rapidly and will be available for all the business critical operations. Next, this server is suitable for the organization that require large database, so it may benefit AIST in the future for storing huge amount of the data. Then, by using this server, it's also able to minimize the total cost of the ownership. Besides that, this server is reliable since it can boost the performance by reducing the possibility of the system or devices fault. The disadvantage of this server is there is no password for the temporary admin account and user cannot be added into it. Next is the SPARC Enterprise M4000. The advantage of this device is redundancy and system link reliability improved. The M4000 server stability. For instance, if the hardware of the server detects a 1-bit data mistake, then it will automatically correct it and send the data. Then it has redundancy in the hardware power and cooling subsystem that will keep the server running even when the power or fans is malfunctioning. Next, it contains mirror monitoring capabilities that can double the data and compare the data received on both sides of the memory mirror during the memory reflectance mode. It also has the extended ECC memory features that will repair the 1-bit error for ongoing processing. And the disadvantage of this server is it's still using a DDR2 SD RAM, where it will limit the performance of this server. Lastly is the Athenos 4000 Model 500 storage. It has the advantage of effective data encryption to meet the expanding storage demand, where it is using 128-bit of AIST encryption to increase the security even when the disks are physically detached. Then it can recover from the disaster because it has advanced copy remote features that can duplicate to many Athenos storage systems without increasing on your server. And both synchronous and asynchronous copying of data is feasible. Next, high-speed backup features is available. Therefore, it can back up to the replicated volume for tape even if it is a backup system. It also contains a variety of useful backup features like OPC function that will help in data transmission rapidly. The disadvantage of this Athenos 4000 is it doesn't support thin provisioning. Thin provisioning features will enable the server to be granted space on a just enough and just in time basis. That's all for my part. Now I'll pass to my other teammate to continue the presentation. Thank you.
Okay, now I will continue to relate the chapter with our case study. First, we can relate our chapter 1, which is Introduction of Server, with our case study. In chapter 1, we learn about server. Server is a device consists of software and hardware that is used to receive and respond to requests sent by clients through the network. Every server, we can classify them into stateful server and stateless server. For example, In our case study, we have database server. Our database server is a stateful server where it will store the previous information request. Okay, so that it will have a stateful, it will always store the information of the previous request. While stateless, it will not store any previous request information. Then we also implement the three-tier architecture. So we have two-tier architecture and three-tier architecture. So in our case study, we implement three-tier architecture. This three-tier architecture, it has advantages like provide data protection, high database server visibility, and application maintenance is centralized. Next, it will relate to our chapter 7, distributed file system. In our case study, we need to provide redundancy, reliability, and scalability. So in the chapter 7, we have the three techniques, which is DFS namespace, that will actually create a virtual file. So create a virtual file for every user to share with every user. Then we have DFS replication, where the file will be duplicated in different server so that it can be accessed by every user, and remote differential compression used to save bandwidth and reduce network traffic. Next, we relate to chapter 8, server security compliance. In case study, we need to provide information security and reduce system vulnerability. So in this chapter, we will use the defense in depth security model. This model, we have basically 7 layers. For example, data layer, application layer, physical layer. Yeah. So for example, we can apply access list control, access control list, and AES encryption to secure our data layer. We also can apply the Windows Server Update service to install latest updates of Windows products on every computer. We also need to implement auditing to track users and operating system activities to prevent damage. In conclusion, we managed to figure out various solutions to solve the issue faced by National Institute of AIST using FCAPS elements. To deal with file management, we proposed Eternus 4000 model, 500 disk storage with OPC functions to provide data backup. To deal with configuration management, Prime cluster is used to implement hardware partitioning to manage resources. To deal with accounting management, we propose to use Fuji's server to provide reliability and scalability. To deal with performance management, we propose SPARC Enterprise M8000 and M4000 server to handle huge amount of data. Last but not least, to deal with security, we apply AES encryption technique to protect our personal data. That's all from us. Thank you for your attention. See you again.